Bismillahirrahmanirrahim. Hello everyone. Welcome back to the another tutorial of past paper MCQs. So the MCQs is the longest flight of Qantas Airways was between. So actually before going to MCQs, I want to declare that in this video I will cover MCQs from 16 up to 30, and this past paper is the QESCO for the post of SDO, and the test was conducted by NTS. So the MCQs is, so in this MCQ, the correct option is the New York to Sydney. Sydney is located in Australia. And this airline is the third oldest airline in the world. In the world, it is the third oldest airline after KLM airline and Aviance airline. So this is the first oldest airline, and this is the second oldest airline in the world. Okay, next MCQ is the 22nd April is celebrated as World Health Day, World Book Day, Earth Day, World Tourism Day. So that is the Earth Day. That was on 22nd April. That is on 27th April, and the World Health Day is on 7th April, and the World Book Day is on 5th March, and the World Tourism Day is on 27th September. Okay, next MCQ is the measurement current transformer CT are step-up transformer, step-down transformer, or one-to-one transformer, auto transformer. So that is actually step-up transformer. In step-up transformer, it will step up the voltage. So in step-up transformer, your secondary voltage will be greater than your primary voltage. But for constant power on both sides, my current must be less than the current on the primary side. So on transmission line, mostly for the measurement of current, we install current transformer. So current transformer will take the high current from the transmission line and will convert that into a low current using CTs. And PT is step down transformer. Okay, next MCQ is if a solid sphere having a positive charge of plus 10 coulomb is enclosed inside another conducting sphere as shown. So inside this plus 10 coulomb, then the charge on outer surface of the outer sphere is here the charge will be same, that is 10 coulomb. Because here we have plus 10 coulomb, so the electric field line will go outward in all directions. So as the electric field lines are coming from the inside of this sphere, but I can say that on this sphere we have lots of positive charge. One positive charge is located at over here, from which I am getting this outward line. Another positive charge is located over here, another is here, another is here. So you can say that the plus 10 charge is located on the surface of the outer sphere. So option A is the correct answer. Okay, next MCQ is what will be the value of the reflection coefficient if a load ZL of 300 ohm is connected to a transmission line having characteristic impedance Z0 of 100 ohm? So first of all, we need to understand that what is meant by reflection coefficient on transmission line. So reflection coefficient is such a parameter which tell us that how much of your electromagnetic wave will reflect back. So this is how much of our electromagnetic wave is reflected back by an impedance discontinuity in the transmission line. So your reflection coefficient, you can say that is equal to reflected signal voltage divided by incident signal voltage. The range of the reflection coefficient is from 0 up to 1. And you can measure it by using this formula. Reflection coefficient is equal to impedance of load minus impedance of the transmission line divided by impedance of load plus impedance of the transmission line. So in this case, the impedance of the load is 300 ohm and the impedance of the transmission line is 100 ohm. So if you put that values over here, so you will get 300 minus 100 divided by 300 plus 100. So that will be equal to 200 divided by 400. So this will be equal to 1 divided by 2. That is equal to 0.5. So plus 0.5, option D is the correct answer. Okay, next MCQ is lock-in amplifier are commonly used to. So first of all, we need to understand this lock-in amplifier. So lock-in amplifier is the type of amplifier which extract a signal with a non-carrier wave from an extremely noisy environment. Like let's say here, this is my lock-in amplifier. And this is the output. And let's say this is the input and this is the another input. This input is the reference input. And this is my signal, input signal, you can say. So let's say my input signal is like this. And reference input is also like this. So this is my reference input. And let's say the environment is noisy. So it let's say that noise affect this input signal. So now we have lots of phases and lots of magnitude. So if we give this noisy signal to lock-in amplifier, so lock-in amplifier will extract this signal with a non-carrier wave. So the output will give you constant amplitude. Instead of lots of amplitude, it will give you constant amplitude of this original signals, plus will give you constant phase. So that is known as lock-in amplifier. Extract high frequency measurement signal from noise? No. Single out the component of the signal at specific frequency and phases? Yes. Introduce noise in the signal? No. Achieve high gain? No. Okay, next MCQ is, in the transformer, the no load current is always remain in phase with the voltage, lag the voltage approximately by 75 degree, lead the voltage by 90 degree, lead the voltage by approximately 15 degree. So actually, first of all, we need to draw the curve. So this will be V1 apply voltage, and this will be E1 and E2, and this is phi. So the magnetizing component of the current will be along the phi this direction, so that is IU, and the resistive component will be in the apply voltage, and that is IW. So that will give us this. So that is the no load current. So this is I naught. You can say this is I naught, and this is theta naught. So your I naught, that's equal to I omega square plus IU square. This is the working component. You can say that this is my working component, and this is my magnetizing component. So the no load power will be equal to, that is equal to no load power, and that will be equal to V1 times I naught, no load current, cos theta naught, where cos theta naught is equal to IW divided by I naught, which is the power factor. Okay, so the correct option is no load current is lag the voltage approximate by 75 degree. So option B is the correct answer. Okay, next MCQ is, according to the bubble theory, once a bubble is formed, it will elongate in the direction of electric field under the influence of electrostatic forces. During elongation, the volume of the bubble decrease, first increase, then return to original volume, remain unchanged. So the volume of the bubble will remain unchanged. Okay, next MCQ is, in a gapped iron core inductor, if the air gap in the magnetic path is increased, it will result no change in the inductance, zero inductance, increase inductance, reduce inductance. So actually the diagram will be like this. Here the input is VT. So that's this is the end turns, and the flux, which is analogous to current, that will flow like this. And this is the ear gap, which have reluctance, that is RG, you can say, and the reluctance of this core, that is, let's say, RC. So in the electrical circuit and electrical analog of this diagram will be like this. If this is here, I have plus, here I will be having plus minus, and this will be RC, this will be RG, this is RC, and the flux T, which flow in this direction, and this voltage source is the MF, which is equal to number of turns time current, IT. So the apply the KVL, so that's will go to N into current, IT is equal to flux into RC plus RG. So normally the RC, reluctance of the core, is very much less than the reluctance of the air gap. So my NIT will be equal to flux into RG. So and also we know that the reluctance is equal to L divided by mu A. So if the air gap in the magnetic path is increased, so if you increase the air gap, so it means you are increasing L. So if you increase L, so it means you are increasing RG. So if you increase RG, so and also we know that my inductance is equal to N square mu A divided by L. So if you increase L, so that will decrease inductance. So option D will be the correct answer. So this is the end of this video. Thanks for watching. If you have any question, you can post that question in the comment box. See you soon in another tutorial. Thanks for watching. Allah Hafiz.